Find the derivative of an exponential function with any base. So in this video, we're going to look at the derivative of an exponential function. And again, this is different than a previous video where we talked about the exponential function. The exponential function was very specific, where an exponential function follows the form y equals b to the x power, which will allow us to take the derivative of an exponential function that has any base, not specifically base e. So let's dive in and look at these formulas. So here we have the derivative of b to the x, and we have the derivative of b to the u because we're going to be dealing with complex numbers. So this derivative is a little bit odd, so it might take a little bit of practice or a little bit of memorization to get this down. But the derivative of b to the x ends up being b to the x times the natural log of b. So for example, if we wanted to take the derivative of, let's just say, 2 to the x power, that would be 2 to the x power times the natural log of 2. And there we have it. Taking the derivative of an exponential function isn't that difficult, as long as you can remember this not easiest formula. Alright, then moving on to our second example here, we can see that we are going to have to use the chain rule here because we have a function inside of our exponential function. Which means we'll take the derivative like normal, or the derivative of the outside, to be b to the u times the natural log of b, but because of the chain rule we have to multiply by the derivative of the inside, which in this case is u prime. So let's go ahead and look at an example. So here we want to find the derivative of 3 to the x power. So the first thing we want to identify here is we want to identify what our b value is. And we can see that our b value is going to be 3. So when we take the derivative f prime of x, that's going to equal our b value, which is 3, raised to the x power, and then we're just going to multiply this by the natural log of b, which again is 3. And there we go. There's our derivative. 3 to the x times the natural log of 3. Alright, in our next example, we're being asked to find the derivative of x plus 2 raised to the x power. So we can see here that we need to use the sum rule for differentiation. And again, that just means we can take the derivative of each term individually. So let's see, f prime of x then is going to equal, well, the derivative of x is just going to be 1. So 1 plus. Now we need to take the derivative of 2 raised to the x power. So we need to identify our b value, and we can see that b is going to be 2. So now we just plug this into our derivative formula. So that's going to be 2 raised to the x power times the natural log of 2. And there we go. That is our derivative. 1 plus 2 raised to the x power times the natural log of 2. Now this next example is a little bit confusing, so hopefully we'll be able to avoid the traps moving forward. But here we have the function 7 times 6 raised to the x power, and we want to find the derivative. Now the trap that folks or that students often fall into is like, oh, I can just multiply the 7 times the 6, and this is going to become 42 raised to the x power. And that is 100% absolutely incorrect. We cannot multiply different bases of exponential functions. So what do we really have here? Well, this 7 is really a coefficient of 6 raised to the x power. So when we take the derivative of functions that look like this, we're going to treat that 7 like a coefficient because that's what it is. So when we take the derivative of f prime of x, again, 7's a coefficient, so we're going to leave it alone. Then we need to take the derivative of 6 raised to the x power. And we can see that our b is going to be 6. So that means it's going to be 7 times 6 raised to the x power times the natural log of 6. And that's it. There's nothing we can simplify because we still can't multiply that 7 with the 6. Different bases, different exponents. So there's no simplifying we can do. So that's it. Boom, boom, boom. Derivative and done. And our final example, f prime of x is, or excuse me, we want to find f prime of x if f of x is equal to the quantity 3 raised to the x power, all raised to the 8th power. So we can see we have an exponential function inside of a polynomial here. Now, this is an interesting problem because we can actually find this derivative in two different ways. And we're going to explore both of those in this example. All right, so the first way we're going to solve this problem is as is. And we can see here that we do have a composite function, which means our outer function is the quantity raised to the 8th power, and the inside is going to be 3 to the x power. So therefore, we can go ahead and we can identify these items. So again, using the chain rule, we know u is going to be 3 to the x, which means u prime is going to be 3 to the x times the natural log of 3. And then we can see that our outer function here is going to be u to the 8th, and the derivative of u to the 8th is 8u to the 7th. So then we can just throw these together. So that means we are going to have f prime of x is equal to the derivative of the outside, which is 8 times the inside raised to the 7th power. We're going to throw the inside back inside, and we're going to multiply by u prime. So we're going to multiply this by 3 raised to the x power times the natural log of 3. Now that is all the calculus that we can do here, so we are going to then simplify as much as we can. So to simplify this, let's see, we're going to have 8 times 3 raised to the x power, all raised to the 7th, times. Now we have another 3 to the x power, and I'm just going to rewrite this as being 3 to the x power raised to the 1st, because that's essentially what it is, and then times the natural log of 3. So if we look, we have some interesting terms here. We have two terms with the same bases being multiplied together. And we have a property of exponential functions where if we multiply the same base, we're going to add the exponents, which means this can be simplified to be 8 times the quantity 3 raised to the x power raised to the 8th times the natural log of 3. And there we go. There is our derivative. But that's just the first method. So now we're going to move on to the second method. And the second method is again taking the original function, which is the quantity 3 raised to the x power to the 8th, and simplifying this to become 3 to the 8x. Because remember, we have an exponential property from way back in algebra that says if we take the power of a power, we multiply the powers. So in this case, we can see here that we have a different type of chain rule. We can see in this particular function, our u is 8x, so that means our u prime is going to be 8. So when we go ahead and we take the derivative, we're going to take the derivative of the outer function first, which is the 3 to the 8x power. And to take the derivative of this base function, remember it's 3 raised to the inside, which is 8x, times the natural log of the base, which is 3. And that step right there was just taking the derivative of the outside function. So now we have to multiply it by the derivative of the inside function, which is 8. And then we can continue simplifying this to get 8 times 3x to the 8th power times the natural log of 3, which is our solution. And you might be asking yourselves, well, those are two different solutions. They look different, but they really aren't. Because if we go back to our first solution, we could simplify this one more step further and make this 3 raised to the 8x power times the natural log of 3 to show that we have the same answer no matter which method we use. Now, whatever method you use, that is completely up to you. It just depends on how your brain works and which one you like better. Both of them are right, both of them are legit, so this is choose your own adventure time. Alright folks, and that is it. That is finding the derivative of an exponential function with any base.